Physics Part 175. We've got the section summary. In a plane polarized wave, the vibrations of the wave are in one direction only, which is normal to the direction of travel of the wave. Transverse waves can be polarized, longitudinal waves cannot. Plain polarized light can be produced from unpolarized light by using a polarizer, such as a sheet of polaright. Rotating and analyzing polaright in a beam of plain polarized light prevents transmission of the polarized light. This occurs when the polarizing directions of polarizer and analyzer are at right angles. We've got section questions. You have been sold a pair of sunglasses and are not sure whether they have Polaroid lenses. How could you find out? Interference. Another content, interference. At the end of this section, you should be able to explain and use the principle of superposition in simple applications. You should be able to show an understanding of the terms of interference and coherence. You should be able to show an understanding of the experiments which demonstrate two-source interference using water, light, and microwaves. You should be able to show an understanding of the conditions required if two-source interference fringes are to be observed. You should be able to recall and solve problems using the equation lambda, which is equal to AX divided by D for double-slit interference using light. Any moment now, unsuspending fisherman, as shown in the figure, is going to experience the effects of interference. The amplitude of the oscillation of this boat will be significantly affected by the two approaching waves and their interaction when they reach this position. We have already met the idea of interference through demonstration of wave properties with the ripple tag. In this section, we shall look at the phenomenon more closely and obtain some important results. The figure shows two waves arriving at a point at the same time. If they arrive in phase, that is, if their crests arrive at exactly the same time, they will interfere constructively. A resultant wave will be produced which has crests much higher than either of the two individual waves, and troughs which are much deeper. If the two incoming waves have the same frequency and equal amplitude, A, the resultant wave produced by constructive interference has an amplitude of 2A. The frequency of the resultant is the same as that of the incoming waves. If the two waves arrive out of phase with a phase difference of pi radians or 180 degree, that is, if the peaks of one wave arrive at the same time as the troughs from the other, they will interfere destructively. The resultant wave will have a smaller amplitude in the case shown in the figure. Where the incoming waves have equal amplitude, the resultant wave has zero amplitude. This situation is an example of the principle of superposition of waves. The principle describes how waves which meet at the same point in space interact.